Hi there, my name is Ron Rogers, and I'm going to tell you about test flying the C-17. This is probably one of the most interesting aircraft I did a flight evaluation on as director, chairman of the ALPA National Airline Pilot Association National New Aircraft Evaluation and Certification Committee. McDonnell Douglas, which in the whole process of this thing became Boeing, was trying to sell this as an MD-17, and there were some very big hurdles to overcome in this process. And as you may be saying, well, I don't recall seeing anything about an MD-17. Well, that's because the hurdles did not get crossed. And I'll tell you about those two big hurdles. But this is an extremely interesting and capable aircraft. And this is also a lead-in to my next presentation, which is going to deal with the crash of the C-17 during the air show practice up near Elmendorf Air Force Base, Alaska, back in 2010. Now, I was out at Edwards in the late 70s, and at the time, there were two prototype test programs going on. There was the YC-14, and there was the YC-15. And both these programs produced a lot of data for the Air Force, and McDonnell Douglas won the competition and ended up producing the C-17. All right, this is the C-17. Now, the first time I was out at Edwards and I saw one of the prototypes landing on the, we had a special dirt strip out there near the main runway that these guys were doing, because this aircraft is capable of landing and taking off from unimproved airfields. That's one of its missions. So I watched that thing land. And first of all, it wasn't landing on the main runway, which is kind of interesting to watch. And then watching him come to an almost immediate stop was quite impressive. But this aircraft has very impressive capabilities. I'll get compliments on my landing as an airline pilot, but I don't usually get compliments from the tower. And I got a compliment on my first landing on this aircraft from the Long Beach Tower. We did a computation. It was supposed to be a short field landing, and we did a computation. The computer said it was going to take 2,652 feet at our weight of 353,000 pounds to stop. Well, I came in, and on my first short field attempt landing, I stopped it in 2,200 feet, which that wasn't too bad. Now, this is a super neat aircraft. That's a picture of me in the cockpit there, and me with the test pilot, instructor pilot for McDonnell Douglas that I was flying with. And the C-17 that I flew, it had that brand new airplane smell. The initial takeoff that I performed was the second takeoff for the aircraft. And it was the 40th aircraft produced. It had 6.1 hours on it when I flew it. Now, why did McDonnell Douglas want to sell this as an MD-17? Well, there were a couple of reasons. One of them had to do with oil fields and taking various outsized cargo into oil fields. And the other one was there is no way to carry a fully assembled 777 engine. If you need to take one like to some diversion station for an engine change because you had a problem, and there's no way to take them unassembled. The engine has to be taken apart to fit in all the current transport aircraft, except for the Russian Antonov 124. And with everything the way it's going now, I'm not sure if we have terribly good relationships with the Russians right now. Well, like I said, the first flight, the new airplane smell was very apparent, and it was kind of interesting. This is definitely a military aircraft. I'm going through the various checks on my first flight of it, and one of the things I heard going through the various, stall warnings and stuff that were enunciated when it was going through the test was missile launch. Okay, I don't usually hear that when I'm going through my systems check on a large aircraft. The other interesting thing about this aircraft is there is no primary attitude indicator as such. It is all done through the heads-up display. Now, this whole process took a lot of coordination for our flight. It took just about over a year. We had a lot of correspondence going back and forth, and I have roughly 10 inches of paperwork on this aircraft. Uh, Great detail in all the systems and stuff like that. And I had visits out to Long Beach to fly the simulator and have all sorts of discussions. And then finally, we got to the point where we were going to have a flight of the aircraft. Now, part of the issue with this aircraft was there were going to be a lot of special conditions. This aircraft was not certified to what you consider commercial standards, and there were going to have to be a lot of waivers basically approved. In fact, the FAA had 2 pages of just, these were just the headlines of the waivers that were going to have to be approved. So they were up against quite a big barrier there. The other big contingency was they were going to have a price tag on this aircraft of $171 million back at the time that I flew the aircraft. Now, there's a little issue with that too politically, because basically McDonnell Douglas was going to try to sell the Air Force, sell this aircraft to a commercial operator without accounting for the development costs that were being paid by the Air Force. And the Air Force says, hey, you're not going to sell this as a commercial aircraft and stick us with all the development costs. You're going to have to sell this thing for a lot more to recapture certain of the development costs. That was a big deal. But as far as a lot of the special conditions, as far as the FAA was concerned, it was kind of interesting because the FAA test pilot on this was a guy named Guy Thiel. And Guy Thiel and I worked together out at Edwards in the late 70s. We both had offices in the test pilot school back when I was a senior flight examiner on the T-38, and Guy was an instructor out there in the test pilot school. So we both had offices out there, and it's kind of funny. We kept running into each other in our careers after we got out in a number of capacities. Mostly Guy as an FAA designated test pilot, and back there in the late 70s, he actually wrote a letter of recommendation for the test pilot school for me. So I knew Guy quite well. And McDonnell Douglas produced a very nice and beautifully slick brochure for the MD-17, and you can see the nice paint job there. And of course, the brochure has a lot of the specifics in that. Now, one thing interesting about this aircraft, it has a function known as powered lift. This is how it lands, how it makes such a short field, steep approach and lands in short distance. The engines are set up so they actually provide a certain amount of lift. You can see in the bottom there where the airflow of the engine blows through the flaps and actually generates lift. And also there's a certain downward deflection of the thrust of the engine that generates a certain amount of lift. And here are the powered lift components. It's got, just kind of a conventional landing flap on the right side. You don't get much thrust due to vectoring on that. But on the left side here, this is the MD-17 with the externally blown flap landing system, and you get a 51% increase in approach thrust, and gives you a very high powered lift component, and lift also due to thrust deflection. You can get almost a 60 knot difference, and I'll show you that here. You can get almost a 60 knot difference in stall speeds due to just the function of powered lift. And you're going to go, well, that's kind of interesting, but do you really want to depend on that? And actually, the system works quite well. We did one of the approaches where on the approach, the test pilot pulled one of the engines to idle on me, and I think it was number 3, and it automatically reconfigured everything. The other engines came up and thrust. I mean, I had to do nothing, and it just like I kept on flying the approach like nothing had happened. But this thing has massive spoilers and massive flaps. And here's a picture of the flaps, and look at that deflection there, and it shows kind of that little blue line shows kind of the slipstream of the air through this, and you can see the slats there. And this is a little information about the flight control setup and the throttles. I'll show you a little bit better of the throttles in a later slide. It's a very interesting design. It uses an A4 stick. I've never flown the A4. I didn't like this stick as much as the Airbus sticks, which is a side stick. It pivots. It pivots high at the center, but it has a full forward and back throw. So that was kind of a natural where you get a full forward and back throw, but you have a high pivot on the ailerons. Now, being good old McDonnell Douglas fashion, they have a backup manual flight control setup, and you can when I went back in the cargo bay area, you could see all the cables running back to the flight controls. They have cables that run directly to the actuator. So in the manual backup mode, if you have no flight computers, you actually go directly to the actuators, and each engine powers its own separate hydraulic system. It's now when you bring in the fly-by-wire component, it's quite it gets quite interesting there. But during the first check part, you do a manual flight control, which you do full swing movements, and then when you operate with the flight control computers, it's a much smaller movement. So it's a little different there, that you're going to use a different movement if you're flying in manual reversion, but I guess you'd expect that, so that's not a big deal. But it's interesting. You do a manual control check first, and then I turned on the flight control computers one by one, and then it goes through an automatic test. Like if you're familiar with a lot of the aircraft, like the F-16, things like that, they do an automatic flight control check. And that takes 3 minutes and 20 seconds. It's kind of interesting to watch because it goes through and it moves everything. It moves all the controls and makes sure everything is working. It's just kind of fun to watch the airplane play with itself there. But it goes through that check. And here's the cockpit. Okay, this thing was really cool. I mean, for people who like knobs and buttons and switches and stuff, this is to your heart's delight here. But like I said, you notice there's an ND down there below the HUD. You can see that little black thing there, and that was one of the issues of crash survivability, because the guys flying this are going to wear helmets. Okay, so if you had a sudden stop, your head's going to hit that black heads-up display mechanism there, but you're going to have your helmet on. That's going to protect you. Well, civilian pilots don't typically wear helmets, but one of the comments I made is, well, the guys that are going to fly this probably fly it in the active Air Force, or they fly it in the reserves, and they would fly this as a part-time job. So I think there would probably be a very big crossover there, and you're not probably going to take people off the street to fly this. But another thing that was kind of interesting is there was no primary attitude indicator. Well, you can see one displayed there over in the center, but that's kind of a little off to the side. That's not in the primary field of view, and you got all these terms and where things have to be and stuff like that. Certification rules, they get to be huge, and things have to be just so. So having a heads-up display, yeah, that's a little bit unusual. And here's in the documentation. I mean, I've got a full flight manual, which was like that, huge, and then they gave me a whole bunch of preliminary brochures and stuff describing all the systems. That's the center console and the forward instrument panel, and then of course you got all the goodies on the overhead panel. Now, the interesting thing about this is it's kind of an unusual throttle design there, and you have a direct lift control switch. Basically, when you're coming in to fly a steep approach on this, you set the approach angle, like you're going to do 3 degrees or 4.5 degrees, and you set that, and then you what direct lift is, you set there with the engines operating at a reasonably good power setting, and you have the spoilers up. It's kind of like driving with your foot on the foot feed and foot on the brakes, which what my sister used to do and wondered why she only got 8,000 miles on the brakes before she had to change them, but I digress. Okay, there it is. I digress. But anyway, the way you can maintain a safe approach is that you've got the power up. So if you need to descend, you just press the direct lift control button. That brings the spoilers up a little bit and you descend, and then you release it, you're on flight path. And if you need to come up to flight path, you just give a little more increase in thrust. So it was a very positive system because you're not dealing with spool up time. The engines are already spooled up. So when you make an input, you get an immediate response, and it's really kind of a really cool system in that respect, and it allows you to fly a very precise steep approach. And I did a number of those, and I'll talk about kind of the specifics on that in a second, but it was very interesting. So I did this, and then I wrote a article for the Airline Pilots Association. Okay, there it is. They're saving the best to last. Again, my flying the C-17. But I got a pretty good spread. I got quite a few pages on the whole thing. And, okay, Northwest Pilots got their contract back in the late 90s there. So that was the main key that got the got the attention on the magazine article. Okay, we start back here at page 28, but like I said, I'm back in the magazine, but I got a good little spread here. We got a nice little centerfold here of the C-17, and that was a great picture. This is kind of like centerfold porn for pilots here, big airplanes like that. So that was kind of a cool spread there, and I think the guys in the magazine, the editor did a pretty good job of putting that together. All right, well, let's talk a little bit about some basic characteristics of the C-17 and design. It uses 4 Pratt & Whitney 2000 series engines. This is the same engine that's used on the 757, and they're FATA controlled, and they generate just over 40,000 pounds of thrust each. And you got a very strong APU. You can start 2 engines at a time. We were just going to start 1 through 4, but as Long Beach is kind of a congested area, and they towed us out on the taxiway, but we're in front of a bunch of little airplane hangars out there, and I'm getting ready to start number 1 engine, and this guy in a Sundowner, single engine Sundowner, taxis up right off our nose, pulls off to the side, and parks at his hangar there, 10 foot in front of my left number 1 engine there. And we kind of had a good laugh with that. We thought, well, that's kind of interesting. Well, let's start number 4 first instead of blow this poor guy away. So we started number 4 and worked 4, 3, 2, 1. And by the time we got down to 1, he had put his airplane in the hangar, which we thought was rather humorous. I guess he's used to seeing C-17s move around on the ramp there. But one of the first things we did, we went through the various checks, and that's when I mentioned I got the missile launch warning, which I don't usually hear during the oral presentations of the warning system. But this was an interesting flight control, the McDonnell Douglas philosophy of manual control there, where you went to the directly to the actuator. So we did that low control check. Then the electronics goes through its 3-minute and 20-second check. The basic flight control system was based on the YC-15, which was their prototype entry into the fly-off competition. And so this ended up being the first large fly-by-wire transport aircraft that they or anybody had produced for the Air Force. And like I mentioned, the center stick, which just a little strange. I like the side stick better. And of course, the full range of motion that you go through the manual flight control check, and then the airplane does its automatic thing. We'll talk about the thrust reversers on this aircraft. They're rather unique because the aircraft is designed to go into unimproved fields. The thing on thrust reversers is you have to worry about FOD damage, blowing up crap on the runway or any place else into the engine and damaging it. And if you're going to operate off of dirt strips and things like that, you got an issue there. So these thrust reversers were designed so they would blow air only in the upward direction. So you wouldn't have this problem. Now that's kind of nice in a couple of respects, because not only can you use full rated N1 power in the thrust reversers instead of typically being limited to a certain value due to the danger or the possibility of blowing debris into the engine. You can use full rated thrust, and it also, because you're blowing the air at an upward angle, it puts downward force on the gear, so the braking is even more effective, and there's also no thrust directed under the wings, which tends to provide a little bit of lift due to the thrust there. So these probably are the most effective thrust reversers you can have, and I'll tell you about operating in the air too, which was a real interesting experience. All right, so I did a normal takeoff, and you can read about that in the article if you want to download it. That was nothing too exciting there with the speeds and stuff like that, fairly standard. But as I was climbing through 8,000 feet, I found that I could easily excite the longitudinal structural mode. A 2.3 hertz structural mode, and also the first order lateral mode, wing bending mode. Now, the thing about this with the 4-engine aircraft and all these aircraft, they're big, but they're still a little flexible, and you can get the things to flex a little bit because the controls are very effective. And the thing about that lateral mode is, and I hear this is common on 4-engine aircraft, is you can get the two engines on the one side kind of out of phase going up and down, and that's kind of interesting to see. A slight bit unnerving, but the structures are strong and the aircraft are made to tolerate that, and you can kind of see that in turbulence anyway. Now, the whole deal with fly-by-wire is, if you want to, you can take that out. You can make what you basically do, though, is you dumb down the airplane. You make it not as responsive. It becomes a little more sluggish. When you don't have those protections in, you have a very crisp response. Now, let me give you an example on the Airbus aircraft. On that aircraft, the tau, which is the rise function on putting the aileron, it's very crisp. It's not a 104, but you can really get somebody's head if you wanted to on the basic direct law mode there, where you're taking all the shape forming of the control stuff. And the airplane has a little bit more than 20 degrees per second natural roll rate in direct law. And initially, they had the maximum roll rate at 20 degrees per second. But they got into a situation where in the flare, they had one of their pilots get into a pilot-induced oscillation. Well, they call it APC now, aircraft pilot coupling, to make it sound like it's not all the pilot's fault. Whatever. But anyway, this guy got into 60-degree banks in the flare, and that's just not a good thing. So they found when they took the maximum roll rate from 20 degrees a second down to 15 degrees per second, that whole little problem went away. So, okay. But Airbus wants the pilot, McDonnell Douglas wants the pilot to be in full control. Airbus certainly doesn't, but McDonnell Douglas, and we can argue that, McDonnell Douglas wants the pilot to be in full control so they can excite the structural modes, they can stall the aircraft, and I'll talk about that in the C-17 air show accident back in 2010 at Elmendorf. I'll talk about that and the aspect of that and the stall characteristics, because I got my own little take on this thing. But that's the next presentation. But anyway, that whole thing with the they're making it so the pilot has the ultimate command authority. So it's like, don't be a ham fist, okay? Otherwise you'll excite the molds. Now, we went up through 15,000 feet, and we did a stall series up there. We weighed 422,000 pounds, and first we did it clean. Now, the clean maneuvering speed was 220 knots indicated. I'm in the clean configuration. I'm slowing. I get the stick shaker at 191 knots, and the stall occurs at 181 knots. And it was kind of interesting. The buffet was very light by comparison. When I did the 777, now we went deeper in the stall. You don't go deep in the stall in a T-tailed aircraft, because if you get too far into the stall, the tail gets blanked and you don't get out of it. There's plenty of people who were killed in deep stalls and T-tailed aircraft, so we don't want to go there. But even on like the 777, we went deeper in the stall, and the bucking motion was very high. But we've got flight test engineers in the back, and the airflow coming off the wings is very chaotic in a stall, and the loads on the tail can get high. So the engineers are back there watching that, and they will call a knock it off if the loads get too high. But I did a few of those in the 777 and noticed it was quite a bit of bucking, really strong. And then it was a turn for next guy to go. Well, there wasn't enough jump seats in the cockpit, so I'm standing back there, and he gets into the buffet, and I start coming off the ground. So I said, man, I better go back and sit down. Now, it's flight test aircraft. The first row of seats is almost where business class was in the 777. So I had to go quite a distance, and the whole interior of these things, it's bare, and there's no fancy stuff. You can see everything, pipes, stuff, a lot of sharp stuff. So I'm going back and halfway back to where I'm going to get a seat. Which would have been, I was in first class. What would it be first class? I actually came off the floor, so I decided I'd better get that pretty quickly and strap in. So I did that. So anyway, I digress. So now back to the stalls with the C-17. So next it did 30-degree flap stall and with gear down. Now in this configuration, the stall speed was going to be roughly 102 to 124 knots, depending on power. 124 knots was going to be with idle power. 102 knots was going to be with a lot of power. And of course, that's the initial warning indication. Now I come back here, and I got the stall buffet at 102 knots. I advanced power and immediately powered out of the stall. I didn't even have to lower the nose or anything like that. And the aircraft just immediately recovered, which was very interesting. But like I mentioned, I wasn't going to get any deeper in the stall because the AOA limiter there, which is definitely a safety situation. And like I mentioned, also the difference in stall speed can be up to 60 knots. We did a few approaches then. We went up to Palmdale, and we did a approach at 3 degrees, did a 4.5 degree approach, and used 40 degrees flaps for that, and approach speed of 128 knots. Now, with this direct lift, it was very interesting. Like I said, the spoilers are partially deployed, the engines are spooled up, and the correction to the glide path was, and it was a little gusty that day, which is typical in the desert, it was a little gusty that day, so we're getting bounced around, but the response was almost immediate. No engine spool up time, anything like that. And I'd been back in the cargo area when one of the other guys was flying, and I noticed there were the personnel back there. There were 6 Air Force acceptance people and 2 McDonnell Douglas loadmasters back there, and I kind of realized they may not have appreciated some of the aggressive maneuvering or the 2G 6-degree bank turn, so I felt a little bit bad about that. But that's the way these the flights go. And I wanted to talk about the descent too. You can place all 4 engines into reverse and descend the aircraft. Well, coming back to shoot the patterns, I did a descent at 280 knots. I was 17 degrees nose low, and I had a descent rate of 15,000 feet per minute, which for being a 727 pilot, I thought this was very respectable. But Brown, one of the McDonnell Douglas test pilots, said that he had done one and he had gotten a 24,000 feet per minute rate of descent. So this aircraft can come down in a pretty impressive fashion. All right, so I come back to Long Beach to do the final landing, and got another nice kind of short field landing there. It's difficult. I have done purposely in flight tests trying to get firm landings to do the qualification of a high sink rate, and they are hard to do. And even on this one, after I'd done several landings, I still brought the nose up just a little bit coming into the flare. Couldn't quite do it. That lengthened me about 300 feet. But this landing gear has the most huge strut actuator there. This thing is huge, and the gear it doesn't come down flat. There's a little twist in the axle, and there's 3 gear and then 3 gear on each truck. So the one gear touches down first, but then as the airplane comes down, the next gear and then the next gear touch down. So you don't get all 3 tires hitting at the same time. There's just a little twist in the axle, and the huge strut, all this kind of lightens the load. Very, very interesting design, and very clever design. But anyway, got a nice landing, and there'd been a little bit of crowd gathered again. I guess they don't see a whole bunch of these airplanes out there, so it was still kind of a new thing at the time. And another nice little comment from Tower about the short landing roll there. So anyway, that was fun, and we taxied back to the parking spot. Now, Boeing was working hard to sell this aircraft, and they have all sorts of bling. They gave me an MD-17 shirt, and the guy said, "Do you play golf?" And I said, "No, I don't play golf, but this is a rag, I guess, to clean off your golf club." So I got that with the MD-17 logo on it, and a bunch of other stuff. Out in my hangar, I have a whole rack of shirts that say, 717, Airbus, Boeing, and all this stuff on them. So I got quite a collection of bling from going on these various flight evaluations. So in the end, the FAA and McDonnell Douglas / Boeing were never able to come to an agreement with a lot of these special conditions. Also, the whole cost issue became a factor because this is going to be a very expensive aircraft for anybody to purchase and maintain, even at the initial price of $175,000 each. They basically they had a current run of my notes back from November 19th of '97. On their briefing that they had a current run of 120 aircraft, and 2005 was going to be the end production date. So if they were going to keep this going for a civilian fleet, they needed to get some orders and get this thing going. And they were anticipating that an operator would own 2 to 5 of these aircraft. As far as transports go, and they're saying it's not as economical as the MD-11. That you can kind of guess because of all the unique features, but it can carry large loads into very short fields. Basically, for crew, it required 2 pilots and a load master, and he would function as the load master and also an emergency function to lower gear and stuff like that. The gear is capable of 12.5 feet per second sink rate, which is very impressive. The FAA has different rules, takeoff and landing performance, which negate a lot of the military numbers. The aircraft would only have a Cat 2 capability, which is, usually that'll get you into a lot of places. So I don't think that was a big deal there. Little things like the airspeed tape was upside down. The little numbers were on the top, which is just kind of a little different. A lot of little other points, just the throttle configuration was a little bit unusual and things like that. But anyway, it unfortunately never came to fruition for commercial aircraft. It would have been very useful for oil equipment, large equipment going to remote sites, and also for carrying engines. But unfortunately, the regulatory hurdles could not be overcome, and the economic hurdles cannot be overcome. Not unusual in development like this, and unfortunately, the production line ended, and that was the end of that. So I hope you found this interesting and informative. Thanks for watching, and I'm going to cover the issue about the accident in the next video. Thanks for watching.